All right, MiniExam 1 demo. So first thing to do is just put your name, and I have no student ID. So the first thing in terms of answering questions here, this is just the academic conduct code. You'll become familiar with this as the semester goes on. This is really just to ensure, we're protecting everyone's quality of work. So all you do is just put your initials next to each of these items, or just give a check mark. Okay, so the purpose of this MiniExam demo is just to walk you through how I would approach questions like this. I haven't looked at these in a long time. I haven't tried to answer these recently, so this will give you a sense of sort of my thought process as I work through these. This MiniExam is set up so there are 2 additional pieces of paper here. So when you turn in your work, it'll just be the first 2 pieces of paper. It'll be front and back in a MiniExam. And then these are just data tables that you'll reference to answer each one of these questions. So here, we're going to start with the first set of data tables. Okay, so let's get started. We have question 1. Oh, who's this? Question 1, about monthly inflation rates. So we have the data table here, and we'll just answer some questions about it. So identify the data dimensions. So here we have month and year. So these are 2 sort of time columns, and then we have inflation rate. So this looks like, to me, this looks like time series. We have, the year and the month written out separately, but it's still a time variable. And then we have inflation rate. So this is time series. And then the variable type. So there's only one variable here, which is inflation rate. These are both time dimensions, so we don't include them as variables. And then we have inflation rate. And this is just a number. So it's in percentages, but it's a numerical variable. So this is numerical. Oh, terrible handwriting. So then the number of variables, this is just 1. These are both time dimensions, so we don't include them as variables. So this is just 1. And then if I were to plot this out, this is time series, and we just have 1 variable. So I would just plot it like this. So, something like inflation rate on the vertical, and then time on the horizontal, and then maybe a line graph like that. Okay, nice. So then question 2, coffee shop locations by neighborhood. So we're looking at this data table. And the first part of the question is what the data structure is. Well, we have IDs here, and then we have neighborhoods. So really the main variable we're looking at is neighborhood. This just tells us that it's cross-sectional. So we have neighborhood, so this is categorical, and you can see that there are at least 3 different categories. So this is cross-sectional, and so let's just write cross-sectional. And then for variable types, we have just it's this nominal categorical variable. So this is nominal categorical. And then number of variables, again, this is just 1. So here, this is cross-sectional and nominal categorical. So this is a great example of a bar chart. The way I would do this, I would just have bars on the vertical axis sticking out along the horizontal, and then maybe I'd order them like this, and then neighborhood 1, neighborhood 2, neighborhood 3, and so on. So nice bar chart. And you can use words to answer this if you like, but I think in general, just drawing a nice little picture can be helpful. So those are the first two. The third, so we're trying to identify the data dimensions of table 3. So here we have a time dimension, so this is in quarters, and then we have multiple stores with some measure, which in this case we can tell is quarterly sales. So here we have the data structure. Well, this is multiple stores through time. So we have both the identifier dimension and the time series dimension. So this is panel. And then we have, for the variable types, this is the time dimension, so it's not included in one of our variables. So we just need to look at this one, or all three of these, I guess. And these are numerical. So this is just a number representing quarterly sales, so numerical. And then the number of variables, we have 3. So this is 3. Okay, nice. And this is maybe a little bit funny because we're looking at 3 different columns for 3 separate categories. But the way we structured this here, I would say this is 3. Although I guess you could make a case that 1 would be appropriate. Okay, so the way I would set this up, we had a similar example to this in one of our exercises. We have 3 different stores and they're both by time. So on the horizontal axis, I would just write time. And then I would have on the vertical axis, this is just quarterly sales. And then I would have, 1 time for A, 1 for B, and then another for C. So 3 line graphs, or a multi-line graph, 1 column, 1 time series for each of the 3 stores. Okay, so then for question 4, we'll jump over to our second page of data. So this is table 4 for employee data. And here we have employee ID, so this is the ID column, and then we have age and annual salary. So the data structure here is, so when I'm just looking at this, I see that there's no time dimension, and we just have employees. So this is cross-section. The variable types, so this is discrete numerical, so it's, integer values. This is also, annual salary is integer values, but we think of it more as a continuous variable. I'm just going to say this is numerical. You could say that the first one is discrete, and the second one is continuous. But I would count any numerical variable as correct in this case. And then the number of variables, here we have 2, so it's age and salary. And then here for the visualization, what I would do is set up a scatter plot. We have 2 variables, and the way we've talked about thinking about 2 variables, particularly when we're looking at numerical variables, is to set up a scatter plot. So I would maybe have age on the horizontal, and then annual salary on the vertical, and then we'll just, put some points. Okay, and then for question 5, customer wait times at a bank. So here we have, so this is table 5. So customer wait times, we have customers, and then the wait time in minutes. So this is, it might be, this is not a time dimension, even though we're talking about time. This is just thinking about wait time, which is a numerical value. So this is ID, and then this is the main variable that we're interested in. So this is cross-section. We're just looking at multiple IDs at one point in time. So cross-section. And then the wait time is in minutes. So this is a numerical variable. And you could say this is continuous if you wished. And I guess for the quarterly sales, maybe to be complete, we'll say this is continuous too. All right, and then number of variables, this is just one. So here we have cross-section numerical. So there are sort of two options we've talked about. One is my favorite, which is the histogram. So on the vertical axis, we'll just have count. And then the horizontal axis will have the different bins. So wait time. And then we'll just have bins. Okay, so nice. So a little histogram. And then for table 6, for question 6, we have product ID. So this is the ID. We have the category. So these are, different types of products, and then we have the rating by category or for the product. So here we can tell this is cross-sectional because we only have IDs, so there's no time component. So let's write this as cross-section. And then the variable types. So here we should be a little bit careful. We have two different variables. So let's just fill this in. This is two types of variables, or two variables. And for the variable types, because we have two and they're very different, we're going to write out both. So for the first one, it's category. So this is, it sort of gives us the type in the name. So this is categorical, but it's also, we can tell it's not binary because there are more than two, and it's not ordinal because there's no inherent order with the options that are given to us. So we would say this is nominal, categorical. And then the second one is customer rating. So this is, again, a continuous variable, continuous numerical variable. Numerical. And this is, I think, the trickiest one to visualize. We've talked a little bit about these kinds of data structures, but the thing to realize here is we could set this up as a bar graph for just category, or we could set it up as a histogram or box plot for just customer rating. But what we actually would want is we'd want the distribution of each category and their customer ratings. So we want the distribution of the customer ratings for each one of the categories. So one way to do this would be with a histogram or a multi-histogram, like we've talked about, where we would draw on the horizontal axis we'd have the customer ratings, and then on the vertical axis we would have the bins for each one of the different categories. But like we've talked about, that can get a little bit complicated. I'm going to write this out. So instead of doing the multi-histograms, we can use just a line plot to represent the height of each one of the histograms. So on the horizontal axis, we'll have customer rating, and then on the vertical axis, we'll just have count. And then we can have, let's say, a line for each one of these. I'll just draw it like this. for each one of the categories. So this is electronics, clothing, and then home, and so on. It looks like those are the only 3 that are in this list. So we could have, a count, a multi-histogram like this that would give us the distribution of customer ratings by group. But we also have the multi-box plot, which I would say is the best choice in this case. We've talked about this for these kinds of applications, maybe a little bit less. So if you use this is a valid and correct answer, but I think this is maybe a better one. So let's say we have electronics, we have clothing, and we have home. And then we could set up the box plots. So on the horizontal axis could be our customer ratings. And then we could set up our box plots. Something like this. And I think this would be a better way of visualizing customer ratings by group, by category. But this, I think, would also be a valid way of expressing the distributions of customer ratings by category. So either way you go, I think these are both great ways of visualizing that data set. And this is very similar to what you can expect on MiniExam 1. I'll see you in the next one.